Good morning to all. Last class, we discussed about the fundamental and derived quantities. And today, we'll discuss about the dimensional formula and how to write the dimensional formula. Today, we'll discuss. So, dimensions of a physical quantity. It means we know that the derived quantities, are depends on fundamental quantities, right? And we are expressing these derived quantities in terms of fundamental, then the powers, it is called as dimensions. Let me repeat. The derived quantities we are expressing in terms of the fundamental, then the powers, it is called as a dimensions. For example, area, we know the formula, it is length into breadth. Length, it is a fundamental quantity, it is indicating with L. Breadth also fundamental quantity, which is also indicating with L. So L into L, which is nothing but L square. So area is actually derived quantity, and we are expressing the derived quantity in terms of the fundamental, then the powers. The power, it is called as dimensions, and method of writing is called as dimensional analysis. Dimensional analysis. And the equation is called as dimensional formula. Dimensional formula. The method of writing is called as dimensional analysis. The derived quantity we are expressing in terms of fundamental, then the powers, it is called as dimensions. Dimensions. The formula is called as dimensional formula. This total formula is called as dimensional formula. And the method of writing is called as dimensional analysis. We know that totally we have 7 fundamental quantities, and those fundamental quantities and corresponding dimensional formula have to see. First one, we have length. Length is a fundamental quantities, and this dimensional formula, it is indicating with the L. And second one is a mass. Dimensional formula is M. And third is time. And fourth, it is electric current. You can indicate with the I, or you can indicate with the A. Electric current. And number 5, it is intensity of light. It's indicating with the CD is a dimensional formula. And number 6 is a temperature, indicating with the K. Or you can indicate theta also, no worries. The last one is a quantity of substance. And the dimensional formula, it is mole, MOL. So these are the fundamental quantities and corresponding dimensional formulas. Now, we are expressing the derived quantities in terms of fundamental. So how to write the dimensional formula for different physical quantities? See, I gave some of the examples here. The first one, area. Area is nothing but length into breadth. Area, which is equals to length of dimensional L, and it is also L, and that is equals L square. Area dimensional formula is becomes L square. Right? And we have to express this dimension formula in the square bracket. So I kept the square bracket for L square. Or also same equation written as Same dimensional formula. There is no m. We have only L square and T0, T power 0. You can express like this also. The dimensions of mass, it is 0. The dimensions of length, it is 2. And dimensions of time, it is equals to 0. And the volume, you know the formula of the volume. That is length into breadth into height. So volume, length, which is nothing but L, breadth also L, length also L, becomes L cube. And the same dimensional formula you can express like this also, because we don't have any mass. So M0, L3, and T0. Now the dimensions of mass becomes 0, length becomes 3, dimensions of time becomes 1. Now coming to the velocity. We know the velocity equation. Velocity is equals to distance by time. Distance, it is also nothing but length. Length dimension formula, it is L, and this is time t. Carry to the numerator, then L t minus 1. The dimensions of the velocity. Is it clear? And you can write velocity also like this, m0 L t minus 1. Now coming to the acceleration. Acceleration means the rate of change of velocity. If you know the formula of the corresponding physical quantity, then you can write dimensions formula very easy. So all the dimensions formulas are based on the corresponding formula only. I wrote velocity, distance by time. Now I'm writing the acceleration, nothing but velocity by time. Velocity already we know, that is L t minus 1. It is a velocity dimensions. And time it is nothing but t, and t becomes numerator, t minus 1 again becomes minus 1, and you will get L t power minus 2 for acceleration. Now coming to the force. We know that according to the second law, force is nothing but product of mass and acceleration. Mass, fundamental quantity, which is m. Area, just now we calculate, acceleration, just now we wrote LT minus 2. So you will get ML T minus 2. These are the dimensional formula for the force. Area, volume, velocity, acceleration, these are actually derived quantities. All the derived quantities we are expressing in terms of the fundamental of, just see force, we are expressing in terms of mass, length, and time. But actually mass, length, time are the fundamentals. So force we are expressing in terms of fundamental, the power series is called the dimensions, and the total equation is called as a dimensional formula. Now coming to the work. Work is nothing but the product of force and displacement. Force, just now we calculated, that is ml t power minus 2. Distance, nothing but L. L into L, it becomes L square. So ml square t power minus 2. Right? Force and distance, corresponding dimension formula I wrote, and after solvation, the resultant work done dimensions becomes ml square t power minus 2. Now coming to the power. Do you know the power definition? Right? We know the power equation, work by time. So try to write the work dimensions. I'm giving 1 minute of time to you. Try to write the power dimensions. Right? Power is not work by time. Work, it is ml t power minus 2. And in a denominator, we have the time. Time becomes numerator, ml square t power minus 2 and t power minus 1, because t taken to numerator, and after simplification, the power dimensions becomes ml square t power minus 3. Now coming to the pressure, the force per unit area. Force. What is a force? Force. This is the force, right? mlt power minus 2. And area already we solved, L square. And L square taken to numerator, L power minus 2. And after simplification, you will get ml minus 1 t power minus 2. And the linear momentum. Linear momentum also indicated with the P. Linear momentum, it means mass into velocity. Mass, dimensional formula m, and velocity already we calculated, lt minus 1, right? Is lt minus 1. So momentum, you will get the dimensional formula of the momentum, linear momentum, lt minus 1. And impulse indicated with I or J. Force and time, the product of force and time, large amount of force acting in short interval of time. Force already calculated, mlt minus 2. And multiplying with time, so t and t power minus 1, it becomes ml t power minus 1. So this is about the dimensional formula of impulse. I hope it is clear, and we'll see some more dimensions. I will see some more physical quantities. Energy. Energy is nothing but the capacity to do work. The capacity to do work, it is called as energy. It means the dimensions of work is same as energy. What are the dimensions of the energy or the work you calculated? mlt power minus 2. Here also same dimensions for the energy. Energy means you can take different forms of energies. You can take kinetic energy, potential energy, heat energy, sound energy, whatever it may be. Energy is nothing but you can take any type of the energies. So for all the types of energies, the dimensional formula is same, ml square t power minus 2. And frequency, this next one. Frequency is indicating with the n. Frequency, the reciprocal of the time period. So reciprocal of time period, that is n is equals to 1 by t. T becomes numerator. So you will get t power minus 1. The dimensions of the frequency. Now coming to the angle. Angle, it is a number 30 degree, 45 degree, 60 degrees. It completes a constant. For constant, there is no dimensions. For numerical constants, no dimensional formula. So angle, there is no dimensions. Next, angular displacement. Angular displacement is indicating with omega. Angular displacement omega is equals to the rate of change angular displacement. D theta, just now I said to you, angle no dimensions, and 1 by t. T becomes numerator. Then you will get the dimensions of angular velocity, t power minus 1. Just check it. Here frequency you got t power minus 1. Omega also you got t power minus 1. Means the different physical quantities have same dimensional formula. So same dimensional formula for different physical quantities also possible. Now coming to the next one, angular momentum. Angular momentum L is equals to product of linear momentum and radius vector mvr, simply m. It is nothing but mass m. Velocity already we wrote lt minus 1. Radius also length. So it becomes ml square t power minus 1. ml square t power minus 1. It is an angular momentum. Now coming to the next one, charge. Charge indicating with the Q. Charge is equals to current into time, IT. I, current is a fundamental physical quantity and its dimensions it is A, or you can write I also. Time it is nothing but T. So dimensions of charge becomes AT. Potential, the work done to carry the positive charge from infinite to within the electric field, that is V equal to W by Q. W is same as energy. Energy is nothing but ml to T power minus 2, and charge, just now we calculated AT. So after simplification, you will get the dimensional formula of potential ml2 T power minus 3 a power minus 1 latent heat. Latent heat, it is nothing but L is equals indicating with the L, that is amount of heat required to change the phase per unit substance. Q by M. Q is a heat energy. Energy is same as work done, nothing but ml square T power minus 2 by mass. Mass is going to be cancelled out. Then the dimensional formula of latent heat becomes L square T power minus 2. Now coming to the next one, magnetic pole strength. Magnetic pole strength is represented with small m. Magnetic pole strength, it is nothing but the product of current and length, that is I into L, that is M is equals to current, the fundamental quantity, which is equals to A's dimensions, length it is L, so A into L, dimensional formula of the magnetic moment, and Planck's constant. Planck's constant indicating with H. H is equals to E by N. According to the Planck's equation, E equal to H nu or E equal to NH. H nu or N is a frequency only. From this, I'm calculating the value of H. H is equals to E by nu. E, energy, ml square, T power minus 2. And frequency already we calculated, T power minus 1. Minus 1 is taken to numerator. The resultant Planck's constant you will get ml square, T power minus 1. Just see here, angular momentum ml square T power minus 1, and Planck's constant also same angular momentum. Just now I said for different physical quantities have same dimensional formula. So it is also possible. Okay. See here, in the case of angle, is a constant actually for this. We didn't get any dimensions. But Planck's constant is also a constant. The value of constant, 6.6 into 10 power of minus 34 joule second. It is also constant, but we have the dimensions for the Planck's constant. It means for the numerical constant, we don't have any dimensions, but for the constant, universal constants, for that we have some dimensions formulas. Okay. See, now we'll discuss about some limitations of dimensional analysis. See some of the limitations in dimensional analysis. So dimensionless quantities cannot be determined. For example, I gave angle in a previous example, right? So dimensionless quantities cannot be determined by this analysis method. This method is not applicable for trigonometric function. This method is not applicable for trigonometric exponentials, logarithmics, logarithmic functions. For this, we don't have any dimensions formula. And some of the cases, for example, the constant proportionality constants, right? In some cases, proportionality constants also have some dimensions, just like Planck's constant I said to you, right? So in such cases, you cannot use this method. Right? So these are the main limitations of the dimensional analysis. And the next class we'll discuss about some numericals, how to solve based on this dimensional analysis. Okay. Thank you.